Now we want to talk about a very important definition, which is function. Now let's look at the definition for the function. A function, we denoted by the letter f, from a set A to a set B, is a relation such that for each element x in A there corresponds to exactly one and only one y. Only one element y in B. Okay, so this is the definition. So the function from a set A to set B is a relation between A and B. Okay, it will map. So this is a general. So this is set A and set B. We have a function. Okay, we have a function f. This f is a relation between A and B. It will map each element x in this set A to exactly one and only one element in B. Okay, only one element in B. So this set is called this f is called a function. It's called a function. So if we often using this equation to denote the function, that is y is denoted by y is equal to f of x. We say y equal to f of x. Say y equals f of x. Okay, this x is called the input, right? Input. And the y, which is called the output. So we input some values, then after some process, we will get the output y. So this process is called f. F is called the function name. The name f is just a name. F could be G, H, K, any number. Is a name of a function. F could be, you can use any other letters to replace this f, like sine, right? Cosine. So this f is just a name. It just tells you that if the input x, then after some process, the process with the whole process is called f, then you will get an output y. Okay, and f of x is, so here x is also called the independent variable. And y is called dependent variable because y will be changed if x is different, right? So y depends on the choice of x. So we say y is a dependent variable and x is an independent variable. So now let's look at several examples. Oh, we should see more. A is here. A is called the domain of a function. Domain of a function f. So, which is the set of all the values you can input. Okay, and the set of all outputs is called the range of function f. Okay, and the range of f should be inside. This is the range inside the set B. Okay, is inside B, not bigger than B, or maybe the same as B, but not bigger than B. Okay, so these are the definitions for the functions. Okay, function is a relation between two sets. It will map one point to exactly one and only one point in another set. So now let's look at, let's determine if this one is a function or not. So we have a set of several students' name. We say Jerry, Kevin, and Mary. Okay. This f function f, this f is the relation between two sets. It will generate, if you input a name, it will generate the phone number. The phone number. Okay. For example, Jerry has a phone number 33403. Okay, phone number. And Kevin okay, maybe. And we have this. Okay, we have 4 phone numbers. So we notice that Jerry has 1 phone number, Kevin has 1 phone number, but Mary has 2 phone numbers because she has 2 phones. Okay, so you can see that f will map the element in the left set to the right set, right? However, f will map Mary to 2 elements in the right set. This is set A and this is set B. So it does not satisfy the definition of the function. So this f is not a function because it maps Mary to 2 elements in B. 2 elements in B. Okay, the function only maps 1 element to only 1 element. Okay, 1 element to 1 element, not 1 element to 2 or 3 or 4 and so on. So this is one example. Another example, we still have these 3 students. But this time, this set B, which is the social security number, This is the social security number. This is F. And we know that every people only have one social security number. So it will map Jerry to this social security number, map Kevin to this social security, map Mary to this social security number. So it satisfies F maps one element in A to exactly one and only one element in B. So this F is a function. Okay. We still look at Jerry, Kevin, and Mary. This is set A. And set B is the date of birth. So this is the October 19th, January 24th. Okay. And this is the relation F between these two sets. Jerry's birthday is October the 19th. Kevin's birthday is also is January the 24th. Mary's birthday is also January 24th. Okay. Although these two elements, Kevin and Mary, have the same output, but it still satisfies the condition, that definition of the function, because it only maps one element in A to one and only one element in B, right? We didn't see the outputs must be different. We didn't see that. It could be the same, right? So it maps one element in A, and the image is the corresponding value in B. There is only one corresponding values in B. This one corresponds to Jerry. This one corresponds to Kevin. This one corresponds to Mary, right? So this is F is a function. Okay, but this one is not a function because there are two elements corresponds to one element in A. And here, there only one element corresponds to each one in A. So this is just some illustrations for the function, if this relation is a function or not. Now let's look at if we have some equations represent a function of x, then we want to know if this equation is a function. Let's look at this one, the first one. X squared plus y squared equals 9. Okay, we know this is a circle. This is a circle. Right? This is a circle. So we want to write as, if it's a function, it can be written as y equals something, right? So let's solve for y. So y squared is equal to 9 minus x squared. Then y equals what? Using the square root property, it's plus or minus square root 9 minus x squared. So from here, if we are given 2, from this expression, if we are given x value, there are 2 y values, right? There are two y values. The output, the input, the one input, but we have two outputs. So that is not a function. So this one is not a function. This one is not a function. Let's look at y minus 4x squared equals 36. So now let's write y equals something. Y equals 4x squared plus 36, right? For each element, we notice that for each input, or for each x, we have exactly one y value, right? So it is a function. So now let's look at another one. Let's look at this one. If given f of x is 4x squared plus 36, so it tells you that if the input is x, then the output through the process, which is 4 times x squared, 4 times the input squared plus 36, which will give you the output, right? So now let's look at some calculation. The first one, f of -1. If the input is -1, what is the output? The f values, this is called f values. F values is called output. Let's calculate. F of -1, we just replace this x. X represent all the inputs, right? So now the input is -1. We just replace x with -1. So it's 4 times -1 squared plus 36. So this is the 40. So the output is 40. Two, f of -x. So now our input is -x. So you replace x with -x. So it's 4 times -x squared plus 36. So this is 4x squared plus 36. So this is the output for the -x. 3. F of x plus h. So now our input is expression x plus h. You just replace this x here with the x plus h. So it becomes 4 times x plus h squared plus 36. Right? And 4 negative fx. So negative means -1 times of fx. So what is f of x? F of x is 4x squared plus 36. So it's the negative 4x squared plus 36. So which is negative 4x squared minus 36. We use the distributive law to distribute the negative side. Okay. Okay, so now let's look at the domain and the range. Okay, domain and the range of the function y equals f of x. Y equals x is the input and the f of x is the output. So here the x input is x and the output is y or f of x. Okay. So the domain is all the x values that you can plug in, you can input. The range is the collection of all the outputs. It's called a range. Okay. So now let's look at example. This is g of x is equal to 1 over x plus 5. So what is the domain? So the first thing is we notice that this x plus 5 is on the denominator. So if it makes sense, you cannot make this one to be 0, right? The denominator to be 0. So what's the x values? It will make the denominator to be 0. X plus 5 equals 0. So it implies when x equals negative 5, then the denominator should be 0, right? So we should exclude this x equals negative 5. Then our domain is x is not equal to negative 5. Not equal to negative. This is our domain. Right? Other numbers you can always plug in except the negative 5. So if we use the interval notation, it is negative infinity to negative 5 union or negative 5 to positive infinity. So this is our domain. Another example, h of x equals square root x minus 16. So here we need our expression under the radical sign should be greater than or equal to 0, right? The square root sign. So we need x minus 16 is greater than or equal to 0. So in other words, x must be greater than or equal to 16. So this is our domain. So in other words, if we're using the interval notation, this is the bracket 16 and infinite parentheses. So this is our domain. Let's look at more examples. Fs is equal to square root s minus 1 and s minus over s minus 4. Okay, so now let's look at what kind of values of s we can plug in. So the first thing is we need s minus 1 is greater than or equal to 0, right? We also need s minus 4 is not equal to 0. So this gives you what? The first one gives you s should be greater than or equal to 1. The second say, okay, s is not equal to 4, right? If you put together, so the domain is s greater than or equal to 1 and s is not equal to 4. So if we're using the interval notation, it would be 1 to 4, 4 is the parentheses, union 4 to positive infinity or infinity. Okay, so this is the domain. There is another one which is called the vertical line test. Sorry, it's a horizontal line test. This test is used to identify a curve is a function or not. Okay, so let's look at this one. We have a circle. We want to know if the circle is a function or not. We just draw an arbitrary horizontal line. Horizontal line means there only one y value, right? So you can see the y values, the same y value corresponding to sorry, I made a mistake. This should be the vertical line test. So we still look at this example circle. Let's look at we draw a vertical line. The vertical line represents one x value, right? It always be x equals the equation for the vertical line is x equals some numbers, right? So for this x, it corresponds to 2 points under this curve. In other words, it corresponds to 2 y values. And we know the function, it will map one x to only one y value, right? But you have 2 y values here, so this is not a function. If you have this curve, you draw a vertical line, there is only one intersection. So in other words, one x value corresponds to one y value. Right? You draw arbitrary vertical line. There is only one intersection. So this is a function. This is a function. If you draw a vertical line, the vertical line corresponds to one x value. So, but we have more than one intersection points. So this is not a point, not a function, because it corresponds to 2 y values. Okay, so now let's look at more examples about the functions. Another example, let's do more calculation. This is the f of x is equal to 2x squared minus x plus 3. So we want to calculate f of x plus h minus f of x over h. So this is called a very important expression, which is called the difference quotient. When you study the calculus, you will see this one a lot, difference quotient. Right. So here is the top is the difference of f values for the different input. The denominator is the difference of the input, because x plus h minus x would be equal to h. So this is called the difference quotient. So let's calculate what's this. At this level, we just need to know how to calculate this one. we just plug in. So here, the input is x plus h. We just replace the x, right, with x plus h. So it becomes 2 times x plus h squared minus x plus h, don't forget the parentheses, plus 3 minus, we use the parentheses, okay? Otherwise, it will cause some confusion for some students. 2x squared minus x plus 3, right? Divided by h. So the next thing is we simplify. This is, we expand it. So this is the 2 times x squared plus 2x times h plus h squared, right? This is the expansion, minus x minus h plus 3 minus 2x squared plus x minus 3, right? Then let's rewrite. This is 2x squared plus 4xh plus h squared minus x minus h plus 3 minus 2x squared plus x minus 3 over h. Let's simplify it. This is 2x minus 2x squared, cancel out. This is minus x, this is plus x, cancel out. Plus 3 minus 3, cancel out. And what do you have? You have 4xh plus h squared minus h over h. So if you simplify, you divide h on the top, the bottom, so it would be what? 4x plus h minus 1. Right? This is your answer. Another example, if f of x is x squared plus 6x minus 24 and gx is equal to 4x minus x squared, find x or x such that f of x equals g of x. So we just write down what is f of x is x squared plus 6x minus 24 equals gx. Gx is 4x minus x squared. Then we solve this equation, right? So we add x squared on both sides, so you have 2x squared. We minus 4x on both sides, so you have 2x here minus 24 equals 0. Right? So now we have some common factor 2, so we divide it by 2, so you have x squared plus x. We simplify a little bit. So now this is the quadratic equation. We can factorize it, or you can use the quadratic formula to find the solutions. So here I factorize it. So what do you have? You have x equals -4 or x equals 3. So you have two x values such that this f of x equals y, equals g of x.